Welcome to Chapter 7. Our goal in Chapter 7 is to create a spiraling staircase. Before we create that staircase, we need to understand a few basic things in Maya. Those would be instances and instantiation, iteration of those instances and how to control that, as well as a study of the units of measurement in Maya. In programming terms, an instance is an object based on a class. How does that translate for us here in Maya? So let's start with the cube. We've used instances up to this point from time to time, but here we're really going to make them the heart of our project. To get a better visual idea of what this cube is, go to Windows and bring up Hypergraph Connections. Inside Hypergraph Connections, we can see the individual elements of this object. So it's made of two essential things. You see 4 objects here, but the 2 that I want you to pay attention to are the transform node. The transform node is the data that you see on the first tab in your attribute editor. It contains your transformations. I think we talked about this once in one of the earlier chapters, but again, I want to make this a focus of our current project. We have the transforms translate, rotate, scale. Those are the ones that are exposed on the channel box. Those are the ones that we are using for animation, modeling, and other common processes in this software. The others that are available here are more for the technical directors or riggers, more commonly known as the riggers of the animation industry, such things as rotation order, pivot points, and other information. So we're most interested in translation, rotation, and scale of the transform node, and node being N-O-D-E, node. The second node to pay attention to is the shape node. The shape node is commonly, when selecting an object in the viewport, is commonly the second tab. And it's the one where all information is fed into it, defining the look and feel of this object. So if we were to perhaps run a bevel over the entire mesh, we can see that the bevel node feeds into, you can see its little arrow, points into the shape node, defining the overall look of the object. Also bearing in mind that we've increased the number of vertices, faces, and edges. Most importantly, the vertices. That's where the data is being held. Different components have different data types, but the base component here that we're most interested in is the vertex. And that's the heavy object, meaning it carries the most data. Because of that data, instantiation is born, meaning we can use this data over and over again, but all of the new objects point to this shape node. So let's see that in action. When you hear me say instantiate, in Maya terms and coming from me, the teacher, I simply mean to create more instances of, and then fill in the blank. That is, to instantiate this cube is to create more of this cube as instances. Imagine this cube as a complex rock, or a tree, or even a human being. And we want to reuse that data, transform it, and maybe even apply unique materials to the various instances of it, all the while pointing at the same basic shape data, ultimately saving file size, so less of a hit on my hard drive, and ultimately saving on render time, because now the render engine only has to look at one shape node when calculating what is rendered, and then draw those pixels at different coordinates in screen space. So the director of my project is happy with my rock, and we want to reuse this rock in the scene. This is the only place other than mail script, that I am aware of in finding instances in Maya, the instance command. It might be hiding somewhere else. I don't know where it is. So here is the duplicate special option box. And in here we can do a variety of simple functions for creating arrays. Notice at the top there's the choice to instance an object or instantiate an object. Make no changes to anything else in here and hit apply. Close that and look at your hypergraph connections. Notice some changes. We have the p-cube shape node has turned pink or fuchsia, and it has two arrows now pointing to an initial group. And we've got this new object that has this red arrow. That, in fact, is a transform node. That's the universal symbol in Maya for transform node. It is also the common symbol in the outliner when you make a group. If I were to group this, notice that the group has that symbol. It's actually not the symbol of grouping per se, it's the symbol of a transform node, because once I've grouped it, I've essentially given it a second transform node for controlling this object. I will ungroup that. Looking at the hypergraph connections once more, notice I have two transform nodes, one shape node that's now fuchsia in color, or purple or pink. Selecting one of those transform nodes and choosing to translate it, W, move it to the side, I now have two objects that borrow the same shape node. So when I manipulate a component or components on the mesh, it will be exactly the same on the other relative to its object space. Meaning, if I rotate this as an object, but manipulate the components over here, let's say I manipulate in component space, I am actually pointing in the same direction relative to its object's center or object space. You can imagine the savings here when creating complex scenes of foliage, cityscapes, crowd scenes. This is the basic technology that allows those massive scenes that you see in movies and even video games. This is the basic principle, the principle of instantiating, or again in programming terms, that is to create a new object based on a class. Up to this point, we have instantiated shape nodes only. And this is the most common way of using instances inside Maya. But there's more to this than just shape nodes. In fact, almost any node can be instanced. The next one I want to bring your attention to is the transform node. So we've talked about the transform node. It's the one that holds your translation, rotation, and scale data. Well, this one can in fact be instantiated as well. It just simply requires you to have another transform node on top of it. So if we look at the outliner, we can see a cube. Come here to display and choose shapes. Notice now we have a plus icon under p-cube. Click that. Notice now p-cube's icon changes to the group icon, in quote unquote, and then the p-cube shape node now has the polygon icon, because this is what's really happening. The p-cube node is the transform node, the p-cube shape node is the one defining the way it looks. We've covered that. But now we can actually see it here in the outliner. So by default, when you select something and you choose to instance it, it automatically searches for the child node, the shape node. The shape node is the child of the cube. So if we want to instantiate a transform node, we need it to be the child of something else. That's where the group comes in, Control G. So now we have transform node, shape node. So selecting the topmost transform node, I can instantiate that one. So now what we get is a pink transform node. And notice that when I select that transform node, all of them are selected. And if I translate that one, they all translate. And of course, relative to their orientation. Which I think is a very good example of what's happening. Sorry, I had snapping turned on for some reason. So now it's nice and smooth, but you can see that it's translating according to its orientation. And they all move just by selecting the transform node. Meaning, if I selected any of these objects, even in the viewport, they would all be selected. So if this is the kind of interaction that you need, this is the way to do it. When you simply want to transform all of them at the same time. Also, their shape nodes all borrow, all of their shape nodes are borrowing this from this one shape node here. So if I select components, it's still true that I can manipulate components and it will manipulate on all of them equally. Another interesting and cool thing about instances is that I can add shape nodes and transform nodes to an already instantiated transform node and have a new object populate in the same position as all of my current instances. It looks like this. So let's say we have a cone and we want that cone to be with each box. So I'm going to middle click, drag and drop the cone in the outliner, middle click, drag and drop it on top of the transform node of the cube. And I get a new cone for each one. And you can see in my connections that I have a new shape node that's instantiated. I can get even a little bit more control here by using one of the tools that I wrote a couple years back, the replace, add, randomize. And I wrote this tool specifically to solve this type of problem and our future problems in our next projects. It's basically the idea is to take another node that you want to swap out a selection of nodes with. So let's say we wanted to put a sphere in the place of those cones. So I could select the cone, control click the sphere in the outliner, and choose to replace, creating instances of it and hitting OK. And now I have spheres in the place of those cones. So initially dropping the cone onto the instantiated transform node somehow made this ghost of a cylinder, of a cone. All I have to do is save my scene, make a new scene, just clear it, and then reload the scene. So it's pretty easy, and it will disappear. So because it's not really there, and I'll make a new scene, and then open up my scene, and you'll see that the cone is gone. The sphere does not have a ghost because I replaced it my way, I guess. We still have the master sphere, if you will, the one that is not in any hierarchy, and then the instantiated ones, following all of the same rules that we've outlined. Let's look at one more example of using the transform node as instanced. Let's go to our outliner and turn off shapes. And let's delete everything. Add a cube to the scene and group it twice. Control G, Control G. With the top level group selected, instantiate it. Use the same settings, it doesn't matter. Continuing with the same thing that we just did, I'll add a cone to the scene. This cone will ultimately be a ghost. Middle click, drag and drop it onto the transform node that's been instantiated, and we know group 1 is instantiated. I can see it in my hypergraph connections. The cone is then instantiated with the cube, and I can now manipulate the cone relative to its parent space, this group. So unlike the example I just showed you, this example allows me to separate between cube and cone. Whereas the last time, the cone was a child of the cube, so if I wanted to replace the cube, I would not be able to. But now I can replace the cube or the cone because I've added a second group the transform node, to do the work of being instantiated. Next, I'd like to investigate how material application to instances works. So let's get a cube and instantiate this a couple of times. Let's not rotate it, just keep it straight, and 10 will be fine. Selecting the first one, well, first of all, we know all of these are borrowing the same shape node. So if I select this first one, my first thought is that if I apply a material to this, it should apply a new material. It should apply that new material to all of them. And we can see that it does not. Now, this looks like it might be a disadvantage, but this is actually a huge advantage. What this means, and this is more clear visually with hypergraph connections, what this essentially means is that we have all of these objects all borrowing the same shape node, meaning that data, the form of it, is only looked at once by the render engine. It has to look at this one node when calculating that. But then I can change its colors and specular highlight, its reflective qualities, and ultimately its textures and UVs can be unique and independent from one another. So this is how you're going to ultimately be able to create that complex crowd scene or forest scene. And you want variation in color and texture, but you want to keep the same form. Maybe you change the scale. That's fine. That's the transform node. But maybe you want the form to be the same and then have different colors and textures for the objects and specular values for the objects. Okay, but what if you do want all of these instances to have the same one? The easiest solution is to select all the ones that you want to have the same material, right-click on them and choose Assign Existing Material. And now they all have the same one. And when you want to individuate one of them, simply assign a new material, differentiating it, and this becomes the new material. Again, take a close look at the hypergraph connections. One shape node for all these cubes, two material nodes, and we can see how many are using this Phong node. We've got one arrow pointing to it. And we can see all of these other arrows pointing to it. In fact, if you hover your mouse over it, you can even read that it says pcube shape 1 dot instance object group number 4. And that's an index array starting at a value of 0. So one of these is number 0, wherever that is, right there, the one on the bottom. So there's an instance objects groups array talking to the material. And then the material defining its overall look. So there's something else we've learned in this little lesson, that the material talks to the shape node and vice versa. The shape node talks to the material. In fact, what we're seeing here, to be more specific, is we're seeing a Phong SG. The SG means shading group. And then this Phong node is the one that you would use in the hypergraph. The shading group is the one that defines extra parameters such as displacement maps, volume materials, and whether or not we're going to use specific mental ray shaders and suppress all Maya shaders. That's what the shading group is useful for. Another efficient way of ensuring that all objects get the same material, instanced or otherwise, is to simply select them all and create a group. And that group, you can see in the outliner, when selecting it, highlights all of them, and I can apply a material to the group. So right-clicking on any one of these objects, choosing a new material, I can assign a blend, and you can see they now all use the blend shader. Unfortunately, they don't remember that they had a different material applied to them just to itself. But maybe that'll change in future versions of Maya. And we can see in the attribute editor that blend has overridden the previous material, even though the material was applied by selecting the group. So it's a way of getting everything instance or not, to have the same material. And if you wish to discard the group, you could select everything and ungroup it. So the group is not required for the material to be applied. We simply used it to apply the material to everything in our selection. Oh, and the group could be a very useful way of organizing a complex scene that all use the same material, like a scene with a lot of pipes or something else. I don't know why ungroup isn't working. Ah, so simple. You can see that I don't use that tool very much. The way that I normally ungroup things, you can see that ungrouping deletes the group as well. Let me undo that just for a second. You can see the way I ungroup things is I've done this. I select the objects. We've done this actually. And I hit Shift P, and that unparents them, but it leaves the group behind. So ungrouping, you just select the group, and Maya will also automatically delete the group. Obviously, a tool I haven't used very often. Inside Duplicate Special Options, you have a ghosted out option called Instance Leaf Nodes. This is only available when you choose Copy. So what does this do, and what does it mean? Leaf node refers to and means the last child in a hierarchy. All right, so earlier we saw that the cube is actually made of two pieces, the transform node and the leaf node, or in this case, specifically the shape node. But the shape node is always the leaf node. It's always the last one. But let's say we grouped and grouped and grouped and grouped, and we had all of these transform nodes stacked. But I wanted to instantiate that cube, but keep all of these transformations independent of one another so that I could make complex hierarchies and animations. But I want the thing at the bottom, what it looks like, to be instantiated. This is where the leaf node checkmark comes in handy. So you would select your upper level group, any one of them, but we'll start with the one at the top and make it easy, and make an instance of it. Apply. So now, when we look at the hypergraph connections, and we look at the hypergraph connections of the shape node, notice that, or the node above it, notice that nothing else is falling into the instantiation. It is simply the shape node, the leaf node. This could be particularly useful, like I said, when you have a hierarchy of controls to manipulate the animation of an object, but you want to instantiate the shape node. So let's see an example of leaf node in action. So I'll delete all of these groups. I don't need to see the shapes. And I will group this cube. Select the cube, not the group, just the cube. Translate it to the side. And we'll see this example again later. Inside Duplicate Special Options, choose Copy with Instance Leaf Node checked. Then set rotation on the y-axis to 36 degrees. And set scale, set number of copies to 10. Or really 9, because I already have 1. So 1 plus 9 is 10. 10 divided into 360 is 36 degrees. So now I've made a radial array. Selecting each cube individually, you can see that I can move them independent of each other. This is good. So if I was making a brick wall and I wanted some bricks to stick out, or I wanted to knock the wall over, but I wanted the shape nodes to be all the same, then this could save a lot of time and energy when processing the data. So now I have the ability to individuate each brick, yet refer to the same object. Selecting the object itself, still I can manipulate that independently because we know that that is a transform node. And now when we get to the component level, they're all connected via component. So if I choose to change the shape of this brick, all of the bricks will change with it. This is good. So this is an example of leaf node. Here's another example of leaf node. I didn't mean to close that. Here's another example of leaf node. Selecting all of these groups and grouping it. So now I have one group controlling all of these bricks. I can then instantiate further using the same setup. So this time I won't rotate. Well, I will rotate. I will rotate. Let's cut it in half, 18 degrees, for example. And I'm going to go up, maybe 1 unit. I'm going to go up on the y-axis. And by now you figured out this is x column, y column, z column. That's how you read these kinds of grids, x, y, z. Okay, and then let's say, yeah, let's go 9 up. So now we've got a well of some kind. And if I select faces on any one of these, they're all connected. So I could select faces here, and I could scale them away from each other, like so. Maybe select vertices and scale those away from each other, and just get these things to fit together. So there's my little well. Each of these layers of the well are individual objects. They can be transformed. They can be moved. Each brick can be individually moved, independent of the others. So, if I wanted to pull this brick out and find out what's the treasure in here, that's where it is. So this is a good way to work to keep things relatively simple, because it's the shape node that's getting instantiated, and we don't have to make a confusing mess with the transform nodes. There will come a time where you will discover strategies on using instances to help lay out things quickly, but then you want to start to make things unique. You want to individuate them even further. So I made it clear earlier that we could make these unique through material, through UV texture and painting. But what if that's not enough? We need to make them unique entirely with a different form. Maybe this needs to be a cracked or broken brick. Well, with this setup, we can easily convert. And we can convert instances to objects. In fact, you may want to add that to your command line, but I'll just show it to you for now. And instance to object. So now we have this brand new independent object, right? Very nice. And it can be moved and shaped independent of the others. And that's instance to object. Again, that's under the modify convert menu. A lot of good stuff inside the convert menu. It's worth exploring. And delete the construction history of this newly created object. Oh, and notice it's still in the hierarchy, right? It's still a part of my well. So if I choose to manipulate, I can still manipulate them and get all the power of that hierarchy, and yet have this one to be unique and different. The last thing I'd like to say about instances and the topic of instantiation is how to use this with a mel command, as a mel command. Go to your help menu and search for Maya scripting reference, mel command reference. In this reference, search by substring for instance. Then click the first one. Here, we can see we have, now the most important thing to pay attention, well, everything here is important, but the thing I want you to pay attention to right now is are the flags. Leaf, Smart Transform, and Name, which is a common flag. The instance command is a very simple command. In fact, to make this even more simple, understand a way in which to find this information, and that is simply to select an object, instance it one time. So we'll go to the duplicate special. All right, then open up the script history, script editor, script history, Windows, General, Editors, Script Editor. In here, you have the top pane is history, and the bottom pane is where you write your mel scripts. So in here I've got a couple tabs with a couple of scripts there already. Notice the command, instance, very simple. Let me make that a little bigger. a very simple command. Highlighting it and the semicolon, drag and drop it to the bottom pane. That's the command. Highlighting it, go to File of Script Editor and choose Save Script to Shelf. Give it a name. And hit OK. And now you have the instance command on your shelf. Go back to the manual and look at one of these flags. A flag is a way of giving a command a subcommand, something else that it should do. So leaf, we've already described. Instances leaf level objects. Acts like duplicate, except leaf level objects are instanced. So what that means is that all we have to do is type -lf and it will automatically instantiate the leaf node. Going back to my command, typing -lf, selecting that one, save script to shelf. And now I have the leaf node version of it. So I guess what I'm saying is that this is the other way that you can create an instance without having to dig into this relatively clumsy tool. This could be a whole lot better. But let's just say you're moving along and you just want one instance of something for a modeling problem. Then these are good options. If you want to edit this command that you put on your shelf, right-click it and choose Edit. And then you can edit it directly in the shelf editor, or you can go back to the script editor itself and say the new name of something should be, and I know it's a string because the command reference says a name is a string, so strings are typed in with quotes. And the new name of my instance will be my instance, and Maya will automatically increment that as my instance 1, 2, 3, and so on. You can copy that, edit a script that's already there, paste it in there, and close it, and it's automatically saved. And when you close Maya, all the changes that you've made to the shelf will be saved. But if you're afraid Maya is going to crash, you can hit the gear icon and say Save All Shelves. And now all the changes that you've made to the shelves have been saved to your Preferences folder. For a deeper look into nodes in Maya and instantiation, I recommend two sources. The first one is the help file that comes with Maya. In there, under the Maya Developer Help DAG hierarchy, you will find a detailed information about nodes in Maya and the relationships to each other and what's legal and illegal in programming terms. What we have been doing is called generalized instancing in this part of the manual. Another good source you can find on Amazon, and it's this book here called Complete Maya Programming, an Extensive Guide to MEL and C++ API. This is an older book. It's published in 2003. And amazingly, it's still relevant because the base programming language in Maya is the MEL language, the Maya embedded language. And it was in here in only the first couple of chapters where the author explains how nodes function and their ramifications on a scene. And I had to read it maybe 4 times and do several examples and do a bit of programming myself before it really sunk in. So this text is partially where my lessons come from. So again, if you want a deeper look at what I have been studying, this is a good book. And there are many other good books out there and more modern books on MEL and Python programming inside Maya. So I just wanted to give you some other possibilities for research if you're interested. Now I want to go through a number of examples of creating many instances and different ways that we can do that. I've already placed on my shelf the duplicate special option box, which again would be duplicate special option box, hovering your mouse over the option box, holding Shift and Control and clicking on it, and that will add it to the shelf. I can right-click any of these icons and delete that from the shelf, and I can click the gear icon and save all shelves, so that will be saved for the next time I launch Maya. Get a cube again and bevel it. And delete the construction history. And save your scene. And then bring up the duplicate special option box, reset it. And my objective here is to show examples of using the transformations, translate, rotate, and scale over a series, over many iterations of the same object. So let's start with something easy. We'll move on the z-axis 2 units, and we want to do that 9 more times. And we want to produce instances, and we'll hit apply. Now, because we're working with just the box, and there's no parent structure, there's no hierarchy, we can safely instance it and not worry about the transform node being instanced. I think I made that clear earlier, but I'm just going to say it again. The transform node, in the situation of instancing a single object that's not in a hierarchy, the transform node is not instantiated. The shape node is the only node instantiated. If creating a row of objects, like we've done here, is needed, but the spacing does not need to be any particular unit, you just need a row of objects, doesn't matter what it is, it could be arbitrary, then using the duplicate special option box might be overkill. Here's another shorthand way of doing it. Under Edit, there's Duplicate with Transform. No option box for that, but it's just a shortcut of Shift-D. In order to start that tool, you have to first duplicate the object, Control-D, then translate it, then Shift-D. And now you've got arbitrary spacing in a row of objects on a single axis. You could repeat that in another dimension, and you can also repeat that. Let's say you wanted to have a slight change in scale as well. So if you were to translate and scale, then hit Shift-D, you could do that as well. The downside to this, and it's a minor downside now that I have this tool, this replace add randomize tool that we've seen me use a couple of times, it really pays off in situations like this. If you're just arbitrarily creating arrays and iterating through an object like this, it might not be good enough to have duplicates all over the scene. That's a lot of data. That's a lot of shape nodes. And since they're all the same shape, we could replace them with an instance version. So let's say we took all of these are based on the same object, and then we selected that one last. So I deselect, reselect, so that one's forced to be the last in my selection. And I could say replace all this stuff with instances, and that's if you don't check mark this little thing right here, it's going to choose instantiation. And then it says how many are selected last. Well, I've got one thing that I want to be the last thing of my selection, and then hit OK. And what happens is it swaps out all of those duplicates with instances. I wouldn't have had a solution in native Maya if I hadn't written this. Opening up the hypergraph connections, you can now see we have one shape node and all of these objects feeding into the same shading group. And each, of course, has its own transform node. If we were to select all of these and hit hypergraph connections, we have all of these transform nodes, so we can move them around the scene, attach them to a particle emitter, or randomly place them onto an object. But they're all borrowing the same shape node, saving a lot of file size and rendering time later on. Watch what happens when we duplicate an instance. This cube is instanced, Control D, duplicating it. We get a new cube, but notice here in the hypergraph connections, it is independent of the instantiated shape node. And if we were to model it, it would be independent. So you could quickly, instead of using, if you needed a new object that's separate from all of the others, instead of using convert instance to object, you could simply select any one of them, duplicate it, and have a new independent object. Let's see what happens when we group a row of them. Group it, holding down D and right-clicking, I'll choose Reset Pivot Position to snap it to center of the selection. Next, I'll duplicate the group, Control D. Move it to the side. Notice what we have in the hypergraph connections. We have a new instantiated shape node with all of the connections of the cubes that are selected. Not a part of the same or original shape instance shape node, but a new one, separate one. So now I have a way to create a new series or a variation of what I had earlier, but all of this group are connected. So interestingly, I thought, well, if it works for one, or if it works for a group, why not work for one in a group? So I Control G grouped one box and duplicated it. And interestingly, I ended up with a single separate node, which makes sense that it is in fact independent, as this row are independent from the original collection of instances. So if I were to select two and group them, these two are instances already, and then I duplicated them, I would then have a new instanced shape node with two feeding into the initial shading group. Two lines, that is, two arrows feeding into the initial shading group. So essentially what happens when you duplicate instanced objects or object and or a single object, it is creating a new instantiated shape node, but if there is only one in it, it defaults to a regular shape node. So this is great information. This basically means that we can build most things to be very much the same shape, change out materials, change out UV maps as time goes on. We learn those skills, creating uniqueness amongst these instantiated objects. And then it comes a point where you need some of these to be a little bit different in shape. So you group those, you duplicate them, you change them. And so you're able to build variations on top of variations without reinventing everything from scratch. You might not need the group anymore. We only used the group to create a new instantiated shape node, a new independent group of objects that we can we can remodel their shape. If we don't need that anymore, select that group. You can either go to the outliner and click the group, or you can select one or all of the objects that belong to that group and hit the up key. That selects its parent, the group, and then go to edit and choose ungroup. And now the group is wiped out, and each object is now at the root level, and we have our shape node separate and independent. And now we can move these around or change hierarchies or whatever we need to do to lay out the scene. Understand something very simple about Maya. Up to this point, at this version of Maya, and to my knowledge, it doesn't like having hundreds of nodes in the scene, specifically hundreds of transform nodes. So even though you're learning how to reduce the number of shape nodes in a scene by taking advantage of instantiation, that still does not change the fact that we have, for every instance, a transform node. So if we produce a number of objects and we go in one direction, and then we do the same thing in, say, a different direction, we very quickly multiply the scene. I now have 100 objects in the scene. If I select all 100 and bring up the hypergraph connections, blow that up and hit A, you can see that all of these, oops, of course I should have created instances. Let's use the replace add randomize to replace them with instances. Just hit OK. Okay, now they're all instances. All right, now bring up hypergraph connections. There we go. There it is. We've got one shape node, and we've got all of these transform nodes, and Maya has to calculate all of those objects. And 100 isn't really a big deal. It's when you start hitting 500, 750, 1,000, and you break 1,000, and you can visibly see not only the viewport slowing down, but just processes take longer to calculate. So what do you do? What do you do when you have a scene where you have crowd effects and plants and all these sophisticated effects? Well, that's where real production stuff really kicks in. So particle emitters, paint effects, compositing and rendering out elements of a scene and compositing them in 2D space like After Effects or Photoshop in post-composition effects. There are a lot of other solutions to solving having a huge amount of content, visual content in a scene. And the two that you want to tackle, if this is something that really fascinates you and interests you, that is not within the scope of this training, the two things you want to tackle are particle emission, particle effects. That's where you could have control multiple objects, thousands of objects along a surface or like fireworks style. And then also is paint effects, which is pretty much the key way of making plant life in Maya. I've seen amazing stuff come from many different artists using paint effects. It just so happens that I'm not a master of paint effects. And again, it's not within the scope of this training. But those are two areas that if this kind of iteration fascinates you, you really want to go in that direction. It's also a very high income side of the special effects field, both in film and in games. And so because there are very few people who understand how to do it. And it does require just a small amount of programming, if not a lot of programming, for those who are at the top ranks of pay scale. But anyway, paint effects, particles, post-comp, rendering the elements out. These are all other solutions for creating highly complex scenes. Okay, so you're thinking, well, what do I do? Well, I don't know how to do paint effects. I don't know how to do particle emitters. I don't know how to do post-comp and rendering out elements. What do I do within the scope of what I know how to do? Well, if creating multiples of this cube was the final piece, beautiful piece, what you would do is say, all right, it's done, but they don't all have to be individual transform nodes. Let's combine them. And that's where you come up here and you select everything that you can possibly combine that doesn't need to be animated. It's just a static object. Well, even if it was animated, we could still combine it and choose combine and give Maya some time. Notice that even on my nice computer, it took a few seconds there to combine 100 transform nodes. And so if you look at the hypergraph connections now, we're dealing with one transform node. And we've got a bunch of connections here because it's leftovers. We have to delete the construction history. So let's delete construction history, and there. Nice and clean. One object, one transform node, one shape node, and now Maya is really happy. So visually, it looks like 100 objects, but Maya on the back end and you know that this is just one transform node and one shape node. And that's how you're going to do it with your current skill set. I want to come back to the duplicate special option box and talk about additive transformation. That's basically what this thing does. So when we say translate on the z-axis 2 units, and this column is the z, this column's the y, and this column is the x. If we translate on z 2 times, I'm sorry, 2 units for each instanced object, what we're saying is z-axis is 0 here, z-axis is 2, and then 4, and then 6, right? So it's not looking at the original position and adding 2. It's looking at the most recently created position and adding 2 units to it. And that's the most important thing here. So let's apply that to something a little bit more complex. Same thing, except this time on scale, enter, say, 0.5, 0.5, 0.5. This is a pretty big change. This is a very big change. And hit apply. And what we're doing is really crushing this object by 0.5 units. Now notice it didn't move nearly as far down the z-axis as it did earlier before we scaled it. That's because, again, it's relative to the scale of the object as well. It's very important to recognize that when you're scaling the object, you're actually scaling its translation space as well. It's one of the reasons why this duplicate special option box could use a major overhaul when it comes to arrays and iteration. It requires, it needs to be rewritten. And I'm sure someone out there has already done that hard work, but we don't have that right now. Scale tends to add a lot of complexity. Scale tends to add shear to a mesh, to an animation. Let's reset this. Instantiate. Move on the z-axis 2 units. This time, let's rotate on the x-axis 20 degrees for no good reason. And let's make 18 of these and hit apply. Whoops. And hit apply. And we get a circular pattern. We saw this earlier. And notice that things are a little bit tilted because it's referring to its own center, not the center of the circle. So it rotates and adds based on its current position and rotation. Now, I know we saw this one earlier, but it is in my list of example of iterations, so I'm going to say it one more time. Move the vertices away from the object. So let's say move them straight up above. And that leaves the pivot point at the origin. Now what we're going to do is rotate around that, right? So we're going to rotate around that pivot point on the x-axis. So in the duplicate special option box, don't translate, set those to 0, but only rotate and hit apply. And now you're going to get that perfect circle. Same idea, if we were to group this, leaving the pivot point behind, we could move the object, not the vertices, which is a big advantage. Then we can hit the up key, selecting the group, and then from there we could instantiate as well. However, as we learned earlier, we have a decision to make. That decision is, do we want the transform node of the cube to be instantiated or not? And now that you know the difference between the two, you can make an educated decision right here. You can say, yes, I want that to be instantiated, or no, I don't want that to be instantiated. So let's go with the no, I don't want it to be instantiated for no good reason. So I would set this to copy instance leaf node, and now only the shape node would have been instantiated, but each object is still individuated, and that's why I would do that option. Finally, let's do the spiraling version of the same thing, leading us up to our assignment in this chapters of production, the production of this chapter, a spiraling staircase. So here we will translate on the y-axis x amount of units. So let's set that to 2, and then we would rotate on the y-axis x amount of units X amount of degrees, and I'm just going to pick an arbitrary number. I'll say 18 degrees, and then we want it to have a certain number of objects, so I'll say 20. I already have one, so I could either make 20 more. I'll make 20 more and hit apply. I'll show you why I'm making 20. So we can take this first one, and I can call that the quote-unquote master object, and I'll just pull that to the side. And the only reason to pull it to the side for me as the artist is so that I could have, and as technician, is so that I can have a quick glimpse of the actual shape of this object without having to look at some complex scene or frame it out. So I can actually separate this and move it somewhere else. And then the remaining pieces, I can move them down X amount of units so that they're on the ground again. So I'll move all of these a relative transform of -2. And so now they all move down -2. So now I can focus on this object, sculpting it. And I can select all of the vertices and move them away from center, away from its own center. And then I can tag vertices on left or right hand side and open it up. Tag vertices on the back side, open it up. And you can see the beginnings of the stairwell, just the beginnings of it. All right, and that would be compound movement, right? So we moved on the y-axis, and we moved on the y-axis rotation, and then we moved the step on the x-axis within its own object space. Our last area to cover are the units of measurement in Maya. And the place to look first that's hidden, I don't think anybody actually looks here, it's the option box of New Scene. And in here, you can define a couple of cool things. First one is you could actually define a default scene. So if you had set up a scene that you want to use all the time with a certain elements like lights or cameras or other things, you can use that as your default scene. That's cool. The next thing is the unit of measurement. The unit of measurement in Maya, the default is centimeter. And the unit angular measurement is degrees. You can see your other option here is radians for angular. And for linear, you have millimeter, meter, inch, foot, and yard. So depending on which client you're working with or which facility you're working in, you might need to switch from metric to standard. But I highly recommend that you always stay on the metric system and stay with centimeters and do all of your calculations, conversions from standard to centimeters. Okay, that said, close that. Come up here to Display Grid option box. In here, there is no reference to centimeters whatsoever because it assumes that you have decided what your unit of measurement is. Also, if I remember correctly, under Windows Preferences, Windows Preferences, here you can define what's your unit of measurement each time you launch Maya. So here we can define, is our coordinate system up axis the y-axis, or is the up axis the z-axis? You would do this if you were working with motion capture data or other 3D programs. Working units here, you can define what you want it to be. You can also define what your frame rate is going to be. So if you're working in Europe TV, you're probably working with 25 frames per second. If you're working in film, 24 frames per second, and so on. And then you can define your own custom rate as well. So this preferences sets it up for each time you launch Maya. This preference up here sets it up each time you make a new scene. And then this preference up here simply shows whatever you've chosen in one of those other two options. So grid options shows you grid based on whatever that abstract unit is. So let's focus on this part next. So let's look at the first parameter, length and width 12 units. This simply refers to what we see in the perspective view. That's all this number represents. It allows us to see as many units as we wish to see. So I could set that to 10, I could set that to 20. Usually we want to have somewhere around 10 because it's just such a huge object if you go higher than that. You could say 100, but it has to draw all of that, and it just creates a lot of visual noise in the viewport. But if you needed that, if you're like getting really, really close and you're making this house or you're making this specific thing that's very precise, that we could open that up and see more of that grid in the viewport. And that's all that first number represents, is what you can see in this perspective viewport. The second number, grid lines every X units. So show me a line which has been colored as this peach-ish color. Show me that line every X units. So let me change subdivisions to 1 and hit apply. What we're seeing is every square here is 5 centimeters square. And by dividing each square into 5 subdivisions, I'm seeing each individual centimeter. And that's what we're seeing. If we needed to see even smaller units of measurement, millimeters, we could cut it down even further. So if we need to see each individual millimeter, 50 subdivisions per. So now we're seeing at the millimeter level. And this might be critical for those of you who are planning to 3D print specific items, or if you're receiving data from an engineer who works in CAD and you need to make adjustments or at least understand measurements, this might be critical. This is a lot of visual noise in this viewport, but it's a crazy amount of visual noise in the other viewports. You can see that it's very noisy in the orthographic views. In fact, it's so noisy that you can see that when I zoom out to a certain point, the grid just disappears. And then if you zoom out further, that grid disappears as well. So there's a threshold to how much these viewports will display. And that's fine, absolutely fine, because I don't need to see all of those all those little tiny squares when I'm this far away. I only really want to see maybe those at the most. And if I need to see even these ones a little bit more clearly, the peach colored ones more clearly, I could change those grid lines to be every 10 or something of that sort. And if I change that and I still want to see millimeters, I have to change this to 100. So the math is very easy with metric. Multiplying by 10, dividing by 10. Add a 0 or drop a 0. I'm going to change subdivisions back to 5. Hit apply, just to clean that up a bit. You can see that I've turned on orthographic grid numbers along the edges. And I find this to be incredibly useful when I'm trying to sell a model and the company requires me to have realistic scale. So I use this to help me measure it in the viewport, and my unit of measurement is centimeters. So as I zoom out, I climb numbers, and of course there'll be a threshold where I really can't see those numbers anymore. And if I have objects that are that big, I'll simply increase the grid lines every value so that I can see larger values. So you have a client who gives you a project that needs to be measured in standard measurement. So inches, feet, yards, and so on. So I come here. I go to Google. I search for convert inches to centimeters. You could probably find an app on your phone. You might find cheat sheets at the library or a bookstore. And I would always have one of those handy. So if I'm sitting at my computer and I've got an internet connection, I'll do it this way. So 1 inch equals 2.54 centimeters. So back in Maya, I will change grid lines every 2.54 and hitting apply. And if I want to see the full 12 inches, change how many are being displayed to 12. Good. And then if we want to see quarter inches, change subdivisions to 8. And hit apply. And now this upper right-hand block is a 1 by 1 foot, and this whole grid is a 2 by 2 foot square, split by 1/8 inches. What's kind of neat about this is if you go to one of the other views and zoom in a bit, you can see visually what 1 inch equals in centimeters, what 2 inches equals. It's just really nice. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's 12. So 30.48. Come back over here. What is 12 inches? 30.48. So once you set this up in Maya, it becomes your visual converter. So you just look at your orthographic view to convert. And then from there, you just make some notes, like I said, or maybe have a cheat sheet that you pin up next to your monitor when you need to do quick conversions to inches or every half foot or every yard and so on. So by doing this, I can avoid converting a file to the standard measurement system, because I know that any additional work that I do beyond modeling will talk to centimeters. So any kind of sophisticated simulation effect is actually using the centimeter as its base unit. And this ensures that everything is equal under the hood, so to speak, but I can model with standard measurements on the top. And I just after a while doing this, you get used to seeing 2.54 equals an inch and 30.48 equals, and so on and so on. Yeah, and just one more time reiterating that the unit of length width, this top number, is only displaying what's here in the perspective view, and more specifically, I didn't say this at first, I'll say it one more time, that it's 1 quadrant of this grid is what this number represents, 1 quadrant. So we actually have 2 feet across the whole grid here.